Y-intercept is 0, 22. Let's get the X-intercept. That's where we're taking the whole function, 2x minus 3 squared plus 4, and setting it equal to 0. I told you we're going to solve this by square roots. That's the easiest method to solve this with. You could do quadratic formula, but it takes a great bit of work to get it to the standard form so that you can even do that. So I always just say, well, learn to do it this way. It's easier. Okay, so the first thing I'm going to do is get the squared part by itself. And the squared part is this stuff. I'm going to move everything that's not highlighted. So the first thing that I should move would be the 4. So move the 4 by subtraction. I've gotten rid of the 4. Now I need to get rid of this 2 in the front. So it's multiplying times that parentheses. So I'm going to divide by the 2. Get rid of it. Now the squared part is by itself. Once you're here, all you have to do is take the square root of both sides. Okay? So if I take the square root, that's just going to get rid of the squared on the left side and give you x minus 3. On the right-hand side, we always put a plus or minus. Because when you take the square root, we don't know if it was positive or negative. That was squared to get the answer. But we've got a negative 2 in there. When we take the square root of a negative, what happens? We get what kind of number back? Starts with a C, ends with a complex number, because it's negative under a square root. This is how it simplifies, I radical 2. You pull the I out for the negative, and then since 2 doesn't have a nice square root or won't factor anywhere, you just leave it there. Now, because that is a complex solution there, it means this thing is not going to cross the x-axis. Okay? It means we don't have any x-intercepts. We've got solutions to this equation, but we don't have any x-intercepts. If we went ahead and solved it, just for the sake of doing 3 plus or minus I radical 2, that's the solutions, but we don't have any x-intercepts. This thing will not cross the x-axis. This is why. Because the complex solutions too. Complex solutions don't cross the x-axis. If we had multiplied this thing out, and I'm going to show you how that works. If you multiply this thing out, and you wanted to solve this with quadratic formula, I'm going to show you that that's possible. The way that you would do that is you would multiply out x minus 3 times x minus 3. Okay? So that's going to give me x squared minus 6x plus 9. Then I'm going to have to multiply that by 2. So that's 2x squared minus 12x plus 18. And then I still got the plus 4 to deal with. So I get 2x squared minus 12x plus 22 equals 0. So there's our standard form finally. And then I've still got to do x equals negative b plus or minus radical b squared minus 4ac divided by 2a. If I do that, my discriminant, the b squared minus 4ac, is going to be a negative number. Okay? Notice that my y-intercept here is c, since we're standard form is 22. What did I find for the y-intercept when I did this one? It's the same. Okay? So no matter which form you're dealing with, all of this stuff lines up. It's all the same no matter which form. This is possible to do it that way. It just takes a lot longer. Every one of them that's in vertex form won't turn out this way. Some of them will be different, okay? Some of them will have x-intercepts, some will not, okay? Look at the graph of that thing. I'll show you that. Hit graph. We see that there's our parabola. It does not touch the x-axis. We know it's opening up, so it's not going to come down any further. There's our minimum at the vertex. we could stretch out our graph and look at the y-intercept at 22. We'd have to go a good ways, but we could get there. What can we say about the domain of this thing? Just to reiterate that idea. What's the domain of this quadratic? Yeah, negative infinity to positive infinity. Always going to be that. The range, because we now know where the minimum is, would start where? What's the lowest y value in our graph? It's that y value that's in your vertex. So it would start at 4 and go up to positive infinity. That's how you can tell the range of that. Be able to kind of discern that sort of stuff too. Now there's a lot of stuff can be thrown in here. All right. Let's do the next form. We've got 40 minutes. 5:05. So let's do intercept form. Intercept form, I may slip up and call it factored form because it's the same thing. Intercept form, factored form, vertex form, and shifted form mean the same thing. Standard form is just standard form. There's nothing. So intercept form, factored form are all the same. Intercept form, still got that same A that we've dealt with forever. Here are the factors of that quadratic. That's what intercept form or factored form is. Okay. If we're dealing with intercept form, getting the intercepts is the easiest thing. Okay. Vertex form, the vertex was the easiest thing. Intercept form, the intercepts are the easiest thing. Okay. Everything else, we probably want to go back to standard form to get. The vertex, the axis of symmetry, we probably want to go back to standard form to get those. Okay, so we're just going to take an example of this. I'm going to take you through the steps of getting a solution for those things. So all of those pieces. So let's take example C, and let's look at h of x equals -6 parentheses x plus 7 x minus 8. Better yet, let's make that x plus 6 and x minus 8. X plus 6 and x minus 8. All right? Now, it's already in factored form. We're going to keep that in mind when we get to the intercept part. Let's go ahead and find the axis of symmetry. This one takes the most work for axis of symmetry and vertex. The reason it takes more work is because we want to use the same formulas for standard form for this one. So what I'm going to do is I'm going to multiply this thing back out. -6 times x plus 6, x minus 8. I'm going to multiply that back out. So x times x is x squared minus 8x plus 6x minus 48. And then I've got to multiply all that by -6 after I simplify. Multiply that out, -6x squared plus 12x plus 240 plus 48, 288. So there we've taken something that was in intercept form and multiplied it back out into standard form. You can do the same thing with things that are in vertex form if you want to. It's not the quickest way. With intercept form is really not a better way that's easily done. Okay. Now, -b over 2a. So -12 over 2 times -6. It'd be negative 12 divided by negative 12, which is 1. X equals 1. So our axis of symmetry is at x equals 1. Do that right? All right. Now, get the vertex. Get the vertex. How do I find the vertex? Plug it into the equation. I can go into the intercept form of the equation, or I can go into the long form of it in the standard form. It doesn't matter which. I'm going to go back to the original and plug it in there, just so that if I made a mistake, maybe I'll catch it here. So that's going to be negative 6 times 7 times negative 7. Negative 6 times 7 times negative 7. 294. Definitely not going to be a pretty one to graph. It's pretty large. So there it goes. Now, here's where it gets nice. The intercepts. Okay. For the y-intercept, we're plugging in a 0, h of 0. So that'd be negative 6 times 0 plus 6, 0 minus 8. Negative 6 times 6 times negative 8. Negative 6 times 6 times negative 8. Positive 288. Does that match the C value from my standard form? Shouldn't they match? C in standard form is always the y-intercept. Here I use the intercept form, and I still got the same y-intercept. So that means I'm doing things right. That's what we're after here. Hey, there's a lot of checking places there. Now, here's the really nice one, the X-intercepts. Super easy because you're taking negative 6, x plus 6, and x minus 8, setting that whole thing equal to 0. Hey, what do you know? That means I only need to worry about the guys that have x's. This negative 6 that's in the front, he's gone. He doesn't work. Doesn't do anything. Really, here's the math that gets rid of him. And then you set x plus 6 equal to 0, x minus 8 equal to 0. If you're in the intercept form, that's what you're going to do. You're going to take each parenthesis and set it equal to 0 and solve it. Get x by itself. Subtract 6. X equals negative 6 plus 8 plus 8. Ordered pairs for those would be negative 6, 0, and 8, 0. And there we have the intercepts for that sucker. Now, domain. It's a domain for every quadratic we deal with. Negative infinity to positive infinity. Don't miss that on the quiz, please. Too easy. Don't miss it on the test or the final. I always ask. That's a question that's on the final every year. It's free, 2 points on the final. Don't miss it. Range. For this one, what's the range? Which direction does this sucker open? Up or down? What's A? It's negative 6, so it's going to open down. So we've got a maximum. So we got a highest point. So it's going to come up from negative infinity to the maximum y value, which is 294. Okay, so our range is from negative infinity to 294. Be able to pull those things off. All right. Do one more thing in this section. With intercepts of 3, 0, negative 5, 0, and 0, 8. Now, because they gave me intercepts, what form do you think I should start with? Intercept form. If they had given me a vertex, what form should I start with? Vertex form. Okay, so that's the only two scenarios you can get is intercepts or a vertex. They gave us intercepts. We're going to start with the intercept form. Okay, so intercept form for this problem is A and then parentheses. You got two sets of them. The X-intercepts are 3, 0 and negative 5, 0. So the factor that goes with those is going to be the opposite. So it's going to be X minus 3 and X plus 5. It always changes the sign. Now, notice I've got A right here. I need to find what that is. What ordered pair have I not used? 0, 8. That's what I'm going to use to find A. Because what is 0, 8? It's an ordered pair with an X and a Y value. F of X is the same thing as what? Same thing as Y. So I'm going to use that ordered pair, 0, 8. 8 equals A parentheses 0 minus 3, 0 plus 5. So I'm plugging in the X and the Y value from the other ordered pair. This one happens to be the Y-intercept ordered pair, but they could give you any other ordered pair that works the same way. Okay? 0 minus 3 is negative 3. 0 plus 5 is 5. Negative 3 times 5 is negative 15. So negative 15A is equal to 8. One step gets A by itself. Our final function in intercept form is negative 8 over 15, parentheses, X minus 3, X plus 5. Could I get that in standard form? How do I get that in standard form? Multiply it out. X times X is X squared plus 5X minus 3X minus 15. All that times negative 8 over 15. That's going to give me a standard form of negative 8 over 15x squared minus 16 over 15x plus 8. I started with intercept form. I was able to get the standard form there. The way to get to vertex form is to actually just find the vertex of this standard form and then plug that into the vertex form. That's the way you do it. Negative b over 2a divided by, and then plug that in and get the vertex. Most of what I'm going to ask you to do is if you start with intercept form, go to standard form. If you start with vertex form, go to standard form. I'm not going to ask you to do all three of them. Quiz-wise. I'll show you a way to get your calculator to help you. Okay. So stats, go to edit. I'm going to clear out these lists that I've got, and I'm going to put those three ordered pairs in that list. So my ordered pairs are 3, -5, 0, and then 0, 0, 8. Just those three ordered pairs. And then I'm going to hit stat, go over to calc. I'm going to have it do a quadratic regression. It's going to give me the A, the B, and the C for that. My C value when I did it by hand was 8, right? I bet the decimal for -16/15 is this. I bet the decimal for -8/15 is this. Okay, I know. That's what they are. If you did the decimals for those, that's what they would be. Okay. So that's a way to check to make sure you're getting the right equation when you go to standard form. Get your calculator to do a quadratic regression. That's always handy to get to. All right. Last section. I've actually got the PowerPoints printed off for these. Copy down the whole problem and the pictures and all that fun stuff that goes with that. Ahead of the game a little bit here on this particular section.
So that's will you be giving us like the formulas or
No, you'll have to input those. Yeah, good question. She asked you would I'll be giving you any of the formulas. That'd be a no.
is that on all of the
It's on it. It'll be on everything that we've done thus far. Yeah. All right. Section 4.4. Let's talk about some application problems for quadratics. Anytime you see something about maximizing or minimizing a situation, you're talking about vertex. Okay? Maximize or minimize, we're talking about vertex. Trying to get something that's the best case scenario. Okay, so here with this problem, a farmer's got 2,000 yards of fencing to enclose a rectangular field. What are the dimensions of that field that enclose the most area? So that implies a maximum out of that. Okay, so anytime you got a word problem, one of the best tools is to draw a picture. So here we have a nice looking rectangular field with some sort of vegetation going. Okay, we have a width, we have a length. They chose to use W for width and X for length. I would use L for length. But anyway, all right. The available fencing comes from the perimeter of the fence of the field. Okay, 2X plus 2W or 2L plus 2W is equal to 2,000. We know that that's perimeter of a rectangle. So one thing you gotta know. The area of a rectangle is length times width. So we're using X times W. We want to find the maximum area that we can create using that information, okay? So we need to get one of those variables by itself. If we solve the perimeter formula for W or X, it doesn't matter which one. Chose W here. We end up with 1,000 minus X. So we just got W by itself, just by doing the math. That's what they're doing right there. That's what you would want to do for any of these types of problems, is get one of those letters solved for. That allows you then to take the area formula and take length times width. Remember, width was 1,000 minus X. So we replace the W with 1,000 minus X. If we multiply this out, it's got an X squared in it, which means it's quadratic. And things that are quadratic we can find the maximums or minimums for. We know this one will have a maximum because A is what? What's A in this quadratic? -1. So we know it opens down. It's a quadratic that opens like this. So it's got a highest point. So from there, what we need to find, since we're trying to maximize that, is the vertex. To find the maximum, you use the same formulas. Negative B over 2A. So -1000 over 2 times -1. That's going to give you a positive 500 for the X value. The Y value, plug that in, it's 250,000. It's square feet. Yeah, area. 500 feet in one direction, and how far in the other direction. So let's get the dimensions. Okay, we found the vertex by doing negative B over 2A, 1000 divided by 2 times -1. Negative 1000 divided by 2 times -1. That's 500. That's the X value. The maximum area that we could enclose is found by plugging that into the area formula that we made up, that negative x squared plus 1000 times x. There we get 250,000 square feet of, or square yards, it's yards, excuse me, for the problem. Then the dimensions are going to be 500 by 500. How do we find those dimensions? Where did we go to get the length or the width, whichever one we didn't find? Think about how did we get, it's a rectangle, so there's a length and there's a width. If one of them is 500, that means this end is 500, that end is 500. So together that's 1,000, right? And we got two other sides. How much fencing did we have to begin with? 2,000 feet of fencing. So that means the other two sides added up to be 1,000 more. So that means each side was how much? 500. 500 by 500. Usually, if you're maximizing a rectangle, it's going to be a square. That's usually the shape that it is. Okay. All right. Example 2 right there. So flip over to that one. We got a list of data here. We want to fit a quadratic function. This is that quadratic regression that I just showed you. You're going to put these numbers into L1, these numbers into L2. Okay. Put the X values, age into L1, the percentage divorce into L2. Okay. Put those in there. Look at the scatter diagram of that. So let me go to my graphing calculator here. I'm going to go to stat, and I'm actually going to put these numbers in because we got time. Just a few more minutes here. It's not much left after this. So L1, I'm going to put 22, 27, 32, 42, 50, 60, 70, and then 80. That's the last one. And go over to L2, and it's 0.9 at 3.6 or 3.6, 7.4, 10.4, 12.7, 15.7, 16.2, 13.1, 6.5. What did I put in X? Or I missed one on the X values, didn't I? 42, 42, 50, 60, got something extra in there. I did miss 37, didn't I? Dang it. That's easy though. 37, 42. I think I typed in 42 over the top of 37 is what I did. All right, 60. 70. All right, 8. All right, got to make sure they match up as far as ordered pairs go. All right, then we take that, and if we go to second y equals and go to stat plot, turn this one on, graph, zoom 9. We can see that that's obviously a parabola type shape by getting that scatter plot. So second y equals, press enter on number 1, turn that scatter plot on. Everything else should be already set up for us. Hit graph, zoom 9. We can see that that's quadratic. That's what's going to clue us in to whether we need to do a linear regression or a quadratic regression. Okay, so I want to do a quadratic regression on that. So I hit stat and then calc, and quadratic regression is going to be number 5. Everything should be set up the right way, L1, L2 for X and Y. Hit calculate, and it fills out A, B, and C for a quadratic function out of that. Okay. So I would write those down somewhere as the equate, as what I'm doing here. So here's that same picture that I just had on the screen. That's that same scatter plot. Here's those same numbers that I had when I did the quadratic regression. Okay, all those numbers are the same. Here they've rounded everything to 4 decimal places, to be the most accurate that they could. Okay, it gave us this formula or this quadratic function that would be able to represent the relationship between age and percentage of people that age divorced. So if you plug in a number for age, 46, you should be able to get something close to what that percentage is of people that are divorced that are that age. That's what that formula or that equation there gives us. You could then take that and find the vertex, which is going to be the maximized area or place where the most people are divorced, what age group is or age that is. And if you do negative BL2A, same negative BL2A we've used all for the last hour or so, you're going to end up with something close to 55. You do that. Okay? And that means that at the age of 55, that's based on our data that we had, that's when the most highest percentage people were divorced out of that. And that was at 15.8%. Rounding, they're obviously rounding there. Approximations. So plugging that into the actual equation, plugging in X, get the Y value that goes with it. That is the percentage of 55-year-olds that are divorced, according to our data. Which, according to natural data, that's pretty small. It's supposed to be around 50%. We could graph that equation. We see it fits the data pretty close. That's what we're after there, okay? So quadratic regression, linear regression, know how to do those with the calculator. That's going to get you a line of best fit and a quadratic of best fit. Okay, so know how to do those things. I'm going to send you in an announcement, I'll send the review for the test that's got everything on it in Chapter 3 and Chapter 4, so that you know kind of more directed what exactly is going to be. You'll have a Canvas quiz this week. It covers 4.2, 4.3, and 4.4, what we just covered today. And that's due Monday, and we'll come in, we'll take our test, and get out of here and have a week to kind of chill out on the math stuff. And we'll come back next week, crank it back to Chapter 5. Okay. If you got questions, on the review or quizzes or anything, email me. I'll get back to you as soon as I can. It may be that I can take a piece of paper and work it out and shoot a picture of it and send it back to you, something like that. But if you run into anything on that review or on the quiz, email me, let me know what you need. That's why I'm here to help you. Are there any questions for me? Yes, that should be option 4 on your calculator in your regression. Line of best fit in option 4 in your regression. All right, guys, you're free to go. Have a great week. Like I said, email me if you got anything that you need help with.